Hello everyone, my name is Jeremy. I'm an engineer at SAY, and today I'm going to be talking about CosmWasm-EVM Interoperability. Actually, my talk shares a lot of similar ideas in Dan's talk, so it's kind of cool that we have overlapping ideas. A bit about me. Yeah, I'm an engineer at SAY. I've been there for around 9 months now. Before that, I was actually an MEV researcher for around a year, and then before that, I was a Solidity engineer at Syndicate for around 1.5 years. So I know this is primarily a Cosmos event, but my background is actually mostly EVM. For those of you who aren't too familiar with SAY, we started out as a Cosmos-based chain. We made some improvements to consensus, which we call twin turbo consensus. This basically gave us really fast block times, and since Tendermint has single slot finality, we have very fast time to finality. So yeah, we extremely performant Cosmos-based chain. And we launched last year in August, the V1 version. And then recently, we actually added on EVM. So this is around 2.5 weeks ago, so very recently. And along with EVM, we added 2 performance improvements. So one is optimistic concurrency, which basically allows parallel processing of transactions as long as the states don't conflict. And then also SayDB, which really improves our state access and commit times. So just overall, we have a very performant EVM chain. And we believe our EVM, the EVM is here to stay, and our long-term goal is to scale the EVM. But today I'm primarily going to be talking about EVM and CosmWasm Interop. So when we were adding EVM, we sort of had 2 options. We could have just made EVM and Cosmos totally separate. Or we could have made them into one chain. In this Say v2 block, you can sort of see the Cosmos and EVM transactions are interleaved. And yeah, that's the route we decided to go down, making them into one chain, putting the transactions into one chain. And then also having EVM be able to call the WASM side in the same transaction and vice versa. So this is sort of what I mean about interop. What I mean when I say interop. So I guess why did we decide to do interop? The main reason is that we had launched Say v1, which was a Cosmos-based chain, and we built up a bunch of TVL on that side already. So we wanted to make all that TVL accessible to the EVM side on day one. So I think that's the main reason. And this has a bunch of consequences. So the first is it eliminates the need for bridging between Cosmos and EVM. So even for things like NFTs, so if you imagine if there was an NFT collection on the Cosmos side, typically NFTs are pretty hard to bridge from one chain to the other. But with our flavor of interop, we actually allow this NFT collection to be accessible to the EVM users through wallets like MetaMask without actually needing to bridge the collection over. So this eliminates liquidity fragmentation and also gives us atomic composability between the 2 VMs. So in this diagram, you can sort of see how an EVM transaction makes a call to the Cosmos side, gets a response, and can do something with that information. And you can imagine a bunch of interactions between the 2 VMs sort of all happening atomically, which is pretty nice. Next, I'm going to talk about how we enable interop. So just basically like 3 big features that we did to enable it. The first is associated addresses, which allow you to take your Cosmos wallet and sort of import it into an EVM wallet, and basically get like your entire like say balance as well as other tokens like CW20 tokens. Precompiles, which Dan talked about in his presentation, and we use precompiles in a pretty similar way. And then pointer contracts, which allowed tokens on the Cosmos side to be accessible on the other side, without the need for bridging. So the first feature is associated addresses. Basically, we allow you to take your private key and import it into EVM wallet, and be able to take your like all your activity and all your balances. So the way it works is there's a simple association process. Basically, you can send any transaction or explicitly send an associate TX transaction type. And then through that transaction, we're able to get the public key and then derive both the EVM and say address from that, and then associate those 2 addresses in our keeper. And then after you're associated, your USAY balance between the 2 addresses are combined, and they match up from then on going forward. So any activity that happens on the EVM side that affects your USAY balance will be reflected on the say side and vice versa. So as Dan mentioned in his talk, precompiles are traditionally used on the EVM side for things like CAC 256, EC recover, basically like common but computationally intensive things that don't really make sense to just implement at the smart contract layer, so they're sort of embedded into the EVM. We sort of repurpose precompiles to communicate between the EVM and the Cosmos side. Like what kind of precompiles do we have? We have a bunch. I can just talk about a bit about these. The WASM-D precompile, which allows EVM to communicate with WASM and like read and write and like instantiate WASM contracts. The bank precompile, which allows EVM users to like interact with native tokens on the Cosmos side, and staking precompile, which allows EVM users to access staking, like native staking on the Cosmos side. IBC precompile, which allows EVM users to like do IBC activities like bridging IBC tokens to other Cosmos chains. But basically this gives EVM users through wallets like MetaMask access to all the native Cosmos functionality that we already have on Say V1. This diagram sort of gives you a sense of how precompiles works. Basically, each precompile is assigned a predetermined address. So, like in this example, like bank has the address 0x001, and staking module has 0x002, and so forth. And then a Solidity contract can just call these precompiles and interact with them just like they would for any other smart contract. So it's pretty simple, like dev experience. Next, I'm going to talk a bit about pointer contracts. Pointer contracts, like a similar concept was mentioned in Dan's talk, but they're basically wrappers around tokens on the other side, and they sort of like forward the calls to the other side. So we have pointer contracts for each token type. So ERC20 pointers to CosmWasm-20s, same for 721s, and also ERC20 pointers to native tokens, and vice versa. And the main thing is that it allows us to actually access the liquidity on the other side without the need for bridging. Yeah, so it's just, it sort of routes the calls to the other side, and the tokens aren't actually bridged over, but we can still access them through pointer contracts. And even our native USDC and USDT tokens are pointer contracts. So on the Cosmos side, we have native like stablecoins, and then on the EVM side, we just use pointer contracts to reference those stablecoins. And this diagram sort of gives you a sense of how pointer contracts work. You can imagine on the right side was like say V1, and we built up, it was just like a Cosmos chain, and we built up a bunch of liquidity in CW20s, CW721s, and native tokens. And then when we added say V2, we got the side to the left. And we deployed a bunch of pointer contracts for these these other tokens, and all the liquidity is accessible just through like EVM wallets. So now MetaMask users like who bridge in for the first time can access all the liquidity from day one. Yeah, that's a bit about how we enable interop on Say. Say V2 just launched a couple weeks ago. There's a lot of apps coming online, and yeah, TVL has been increasing. Yeah, and we love for you guys to try our chain out and give us feedback. Yep, happy to take any questions. Thank you.
This is super cool. Thank you. I guess the one bit I have a question on is sort of like from the wallet side, from like a user perspective or app side, right? Like I've got Kepler, and I might have MetaMask, right? Can you talk about like that part of it, right? Like if, for example, like I'm using Kepler and I want to make an EVM transaction in the system, or if I'm using MetaMask and I want to make a WASM transaction in the system, can you talk a little bit about like that part of the interop?
Yeah, so I don't really know about Kepler, but we work with a wallet called Compass, and they sort of build a custom solution to have both the Cosmos and EVM stuff in the same wallet, which is really nice. And then for MetaMask, I guess typically like a dApp would build a Solidity contract to use our precompiles, so that then they can access the WASM easily. Or you can forward it. You can forward your calls actually directly to. You can make calls directly to the WASM precompile if you want. Yeah, some apps like do it that way.
All right. Thank you. When you said that you make atomic like transactions, what do you mean? Because you were talking about the TVL is on Say.
Yeah.
And then if there was an IBC transfer, you're not necessarily minting, right? In this case, you said atomic, so there's a. I'm just kind of curious how you manage the contract as a deposit or as an actual hash or lock contract, or.
Yeah, I meant like atomic in the sense that the Cosmos side and EVM side of our chain, those like calls would be atomic. So like if you're making IBC calls to other Cosmos chains, like that would not be atomic, I think.
And the liquidity remains on Say?
Yeah, like basically like the EVM transactions are like wrapped in a Cosmos transaction, and the liquidity is all just like on the Cosmos side, and yeah, so it's just all on Say, yes.
Okay, I'm curious how that works, but.
So for telling the associated addresses, that's a manual process, right? So if I'm a user and I go into one of these wallets, I have to somehow indicate in the UI that I have a CosmWasm wallet and an Ethereum wallet, and they're connected, and I'm the same user. Is that right?
Yeah, you just have to take your private key and then import it into another wallet, and then do a simple association process, just like you can go to like app.say.io and like we'll like help you associate it just through signing just like signing any transaction basically. And then you basically get like the say address that was derived from that private key and the EVM address derived from that private key like matched up in our keeper.
And then when I take that address to another wallet that I want to use, I would have to import that private key that is now this matched up EVM and Cosmos wallet?
Yeah.
Okay,
so if you take the same private key and go to another wallet, yeah, it should derive to the same address.
And I can do that either on the EVM side or the Cosmos side, depending on which wallet?
Yeah. And
Okay.
it should, the private key derives to the same public key. Or, the same address, yeah.
Got it.
Maybe also a question or also a comment on this address part. I think there were two questions about the addresses. So I think it really depends on the key derivation path and the coin type that you use. I'm not sure how it's on Say, but I think the chain needs to kind of decide whether or not you want to support like several coin types, one that's maybe more the Cosmos standard or the EVM standard. But I find that like whether or not you represent something as beg32 or hex, that's just a different representation of the public key, right? So I think also maybe sharing their experiences on DEVMOS, like when we launched, we said, okay, we just have the Ethereum coin type, right? And then we said, okay, that's the only one there is, and you can use Kepler or MetaMask to interact with both Cosmos or Ethereum transactions. That's all possible, like with the signing. But as soon as you start having two different coin types, then you get into this problem of how to kind of connect them. And so I guess that's where these pointers are quite useful. And I guess my question is, like, are you guys basically just storing this the difference of the representation, the beg32 and the hex on the chain state? Is it that what is the linking or?
Yeah, after the link, we just store those two beg32 and OX addresses in our keeper.
Cool.
Yeah.
All right. Thank you.
Yeah, we did have a sort of an issue with the coin type thing. Yeah,
Which one do you use on Say then? Like the Cosmos or Ethereum one?
We use different coin types on each side. But yeah, I think the private key, like the sort of like the hex private key, is like the same. Just like the passphrase to private key might be different between the two sides, I think.
Okay, thank you.
So on liquidity fragmentation, it sounds like it's basically kind of blending the state together on both sides. But for practical purposes, like if you have Uniswap on the EVM side and then you have a Uniswap equivalent on the Cosmos side, like it's pretty likely that if pools are made on both sides, that liquidity is actually fragmented in that sense, even though it can be accessed. Okay, got it.
Yeah.
Could you build pointers in the other direction? Like, can CosmWasm contracts call EVM contracts?
Yes, yeah, we have those as well. Yeah.
Anyone else? All right, thank you, Jeremy.
Thank you.